This call is now being recorded.
Okay. Uh, do you know what is the meaning of this command?
Changing the directory to the desktop folder.
I can't hear you.
Changing the directory to the desktop folder.
Okay. So in this folder, I am going to build the necessary files, whatever is required. So let me show you how the surface looks like. So this is my script for my surface. So it's a 100 cross 100 cross 1 surface. Okay. So I'll load it in VMD and show you how it looks. Can you see the surface?
Yes.
If you do this, you can see the beads completely. The bonds will be deleted. So the next step is to create a PDB file of this thing. Do you know how to create a PDB file? Huh? So the PDB file is generated. Okay. How will you know it's generated? Look over here. So this is a PDB file. This is how it looks. So the next step is you have to generate the water molecules. So I am going to show you a random box. Your work will be to get the correct box which keeps the density of the total system to 1. Okay. Hello.
Yes, sir.
I mean, that is something you have to do. I'm just showing you a trial how to uh, build a setup. Okay. So you have to select the minimum coordinates over here. As your surface starts with 111, okay. So your minimum coordinate should be 1, 1, and 1. And maximum, it depends on how much you want to build your box. So say let us keep it at 20. We press solve it. So change the name to solveit.1. Okay.
Yes, sir.
See, very few water molecules are generated. So now what you can do is you can actually increase it. I hope you can see the water molecules. Okay. So this will give you two files, solvit1 pdb and solvit.txt and a solvit psf file. Okay. You can see the files, right? These are the three files that have been generated right now. Okay. So now what you do is delete everything. Load the surface pdb file. This is the surface pdb file. Now what you have to do is you have to locate the center. So how will you locate the center? Do you know that?
So we know the size of the particles that we know the boundary of the box, so we can calculate it manually.
Manually. You don't have to do anything manually over here. Wait. So these are basically the tools that you will need to do whatever we are doing and now onwards. Okay. So these are the two commands that you have to select. See, you get a value. Can you see this?
Yes, sir.
Just write. I mean, you have to write these commands on your own. Okay. Remember, whenever you are going to see this video, you have to type these commands. Make sure all the spacings are correct, else you would get error. Okay. Did you get my point? Okay. So remember this coordinates. Now I'm going to delete this. Okay. Let it be there. Doesn't matter. So now if you check the VMD script, this looks something like this. Okay. So our idea is that we have to move this water box somewhere in the middle. Okay. It has to be moved somewhere around here. Are you getting my point?
Yes, sir. Yes, sir.
So just do the same thing again. Now you can see a different center. This is the center for the water box. Okay.
Sir, how do we move out? How do we move out of that surface? तो मतलब कि सिस्टम में कैसे पता चला कि हमने अब सरफेस की जगह वाटर का सेंटर निकालना है?
It just happens. I mean, there is a logic, but if you load one after the other, the second one will be active. So that is why I didn't load water initially. Okay. Always load the surface first, then the water. Surface should be fixed. You have to move the water. Okay. Do you understand that?
Yes, sir.
So see, now you have 25 this thing. So basically you have to move these things to around 25, right? 25, 25, and this has to be moved around -9. So what you can do is, so these are the two commands that you have to use. Anyway, it's already selected. So I have to write. So you have to move the box, right?
Yes, sir.
So if you write this thing, now let's keep this open, and I'll also keep this open. Let's see what happens. See, the water molecules are almost at the center.
Yes, sir.
Okay. Now you have to keep in mind one thing, that these water molecules must not cross the surface. Okay. You see, these are crossing the surface over here, right? Hello.
Yes, sir. I'm listening.
Just respond, okay?
Yes, sir.
So now you have to move the coordinates again.
Yes.
So keep them 0. X and Y are fine. So you have to move the Z axis. So you have to move it again. It's still, some of them are outside the surface. See? Let's move it by 3. Almost. Okay.
Yes, sir.
You can see this.
Yes,
It
sir.
doesn't matter if you keep the water molecules above the surface, okay? But it can't be below the surface. If it's below the surface, the lamps won't run and it will show errors. Okay. So now what you have to do is you have to save this thing as a PDB file again. Okay. PDB file for solve it. Okay. So this is the name that I am giving.
Yes, sir.
So if you look in the folder, see, this is the file that has been generated.
Yes, sir.
Okay. Now what we have to do is we have to merge these two PDB files. Okay. So delete everything, because if you don't delete everything, the VMD may take some jargon values. Okay. So load the surface first. Load the water molecules one. The new one. Okay. The sol one that you just generated, not the previous ones. Okay. So now if you look over here, you can see they're all above the surface. Yeah. Fine. Is everything clear till now?
Yes, sir. So just in this last step, when we have already solvated the surface and the water together, why do we need to load the surface file?
No. We haven't. See that surface was just a reference so that you can set your water molecule. Now you will merge them. Where did you merge them?
Yes, sir.
You will merge them now. So the next thing you will do is this is the stool and this is the way it's merged. So it's showing an error. Why is it showing an error? Now you have to look over here. See, I have written mole ID 1, mole ID 2. Okay, you just have to type the IDs. For example, here it is 8 and 9.
Yes,
Okay, so you have to write 8 and 9. Okay, just press enter. Now you have to generate the PDB file again for the merge system this time. Okay, try to generate the PDB and PSF together because the PSF will be important later. Okay,
yes, sir.
so now you have, whenever you have a generated, I mean you have combined both of them, it will look something like this. The color changed. Can you realize it?
Yes, sir.
Okay, so just let me give you a visual of how it looks actually. I think this is better.
Yes, sir.
You can see everything.
Yes, sir.
This is the water molecules and all.
Yes, sir.
Okay, now there is something that you have to do manually. Okay,
Okay, sir.
so let me show you. Where is this? So this is the PDB file that you got. Okay,
Yes, sir.
now select everything from here. Go to Google Docs. I mean Google Sheets. Just follow the steps that I am doing, else you will get errors. Just paste them over here. Okay. Delete this first row. Okay. Delete the last row. And now select this column. Go to data. You have to select split text to columns.
Yes,
Okay. You know this.
yes, sir. मतलब, I am understanding it, sir.
Okay. So now it's space. It will take a bit of time because there are a lot of datas.
Yes, sir. Sir,
Yeah.
I did try to run that XYZ file on the VMDB, but sir, one molecule was not loading.
It won't load because you didn't write the number of molecules. I'll show you. Wait. Yeah. Let me stop this. Okay. So what we need from here is only these coordinates. Okay. So basically you have to delete everything up to here. Okay. Now you have to delete this. Yes.
Yes, sir.
Now just select this, insert a row to the left, and paste everything over here. Okay. Now just check if everything is fine. See? Yes, everything is fine. So now delete this thing. Okay.
Yes, sir. Yes,
Now you just have to copy paste. Open a word pad. Okay.
yes, sir.
Paste it over here. Select everything.
Yes, sir.
Just you have to change the formatting over here. Okay. Can you see what I'm doing?
Yes, sir. Lammps specification.
Okay. So now the thing is you have to write on top of this. Okay. So how many molecules are there?
Uh, 10,000.
You have to be exactly correct, else it will show an error. So it's 14155. Okay. The next thing is the box size along the x-axis. Okay. Now you have to save this file. The way it should be saved is I'm showing you. So it should be saved as whatever name you want to give dot xyz. Okay.
Yes. So does it
So
matter
now
if we use capital X, Y, Z or small in the extension?
uh,
So does it matter if we use capital X, Y, Z or small X, Y, Z in
no,
the
no, no, it doesn't matter. Okay. So now this is the file that has been generated.
yes,
So now let's see if it's actually a merged file or not in VMD. So delete everything that we had previously. So everything is fine, right? It's merged.
Sir,
Can
the
you see
color,
this?
yes, sir, the color has changed back to this.
That doesn't matter.
Okay.
You can select any color you want. That is unnecessary right now. Anyway, see, everything is fine, right?
Yes, sir.
So now what you have to do, since you have the coordinate files, each atom or each molecule should have their own charges and everything, right?
Yes, sir.
So you have to use Topo tools to do those things. So everything is written here. So when you will do your stuff, write each step from here and do it in VMD. Don't copy paste like what I am doing now. Okay.
Yes, sir. Yes.
So now you have to write. So there are some things you have to understand over here. So the total number of chains. So basically, how many water molecules are there? It's
14 point.
basically this divided by 3.
Yes, sir.
4155 divided by 3.
Yes, sir.
1, 3. What is the answer?
3718.
Do, huh?
3718.
Wait.
471.
It's 1385.
Divided by 3, sir.
Huh?
14155 divided by 3, sir. No?
No. Why?
There are
There are
two
1000
numbers.
molecules on the surface. 10,000 surface molecules. We'll only take the water molecules.
Okay. Yes, sir.
So write everything in VMD one by one. You write one line, press enter. Then you go to the next line. Okay. Did you understand what I'm telling you?
Yes, sir.
Tell me if you are not able to understand right now, because I won't spend another hour explaining this again.
Yes, sir. I got that.
So write everything in VMD. So your initial file is generated. Okay. The file that you have to use in Lammps is generated. Okay. This is the file.
Yes, sir.
So you see everything is here.
Yes, sir.
Just check if everything is okay or not. It will be okay because it's already coded. So that's it. That's basically how you generate your Lammps input file. Sorry, Lammps data file.
Okay.
This is your Lammps data file.
Yes, sir.
Now there is one more change that you have to do. You have to select all these. Uh, so basically, the surface will move or the surface will remain stationary.
So it's stationary.
Huh?
The surface will, will remain stationary.
Okay. So there are two types of atoms here, right? One will move and another one will
Be
be
fixed.
fixed. So you have to differentiate the atoms. So what differentiates one with another is, you see, everything after the index number, everything is 111. See this? This is the ID. So you have to change this. So from where the water molecule starts, select them, select till the end, go to the sheets, make everything 2 over here. Why did I make everything 2 over here? Huh? I just explained it to you.
because one of the particle is moving, whereas the other one is
Not one of the particles. Be
one
technically
of.
correct. One type of particle will move, one will be stationary. So make everything 2 over here. Okay. Then come back here. Just paste it. Okay. Now replace. Do this, else there will be errors. The spacings have to be correct. Okay. Save it. So this is everything. You are ready. Your configuration file, your file is ready. Okay. So now what you have to do is, wait, just let me check one thing. So you can see the droplets is being spread, right?
Yes, sir.
So this is for a very small number of molecules. So for your system, you have to do it. Your system is very, I mean, comparatively much higher. Okay. So then there's another thing. Hmm. So you have to see what is going on in your system. You need to uh, have a PSF file before you load the trajectory file. So Topo read Lammps data. This is the name of the configuration file that you just generated.
Yes, sir.
Sorry. This is the PSF file you are generating. So now you have the PSF file. Okay. So when you load something in VMD, you have to load the PSF file. And this is the PSF file.
Yes, sir.
System.psf. You have to load this file. Then on this you have to load the trajectory file. Did you get what I said?
Yes, sir. On the PSF file of the system, we have to load the trajectory file.
I'll show you. First load the PSF file,
Yes, sir.
then load the whatever trajectory file you have.
Yes,
Okay, that is the way these things should happen. That's all.
sir, can you tell me again about this trajectory file? Where did we generated
Huh?
that? Can you explain once again about the trajectory file where we generated that also?
No, trajectory file you have to generate, right? Trajectory file is generated from the Lammps script.
Sir, can you explain more about it?
This is the script file for Lammps.
Yes, sir.
Okay, so the outputs are stored in a trajectory file.
Yes, sir. Yes, sir. Okay, yes.
That is what I'm loading.
But I think I used some other extension, .prg file.
Huh?
I think I used some other extension for the trajectory file,
You don't need to
.prg.
use anything else. Do whatever I'm doing.
Okay.
You use whatever you can. I mean, you had a lot of time, but you didn't use it. So now do whatever I'm doing. Use this script file. Replace this. I mean, you have to look for the variables over here. Pair coefficients you have to build on your own. I don't think these are valid for your system. This is for carbon system. You have to use for silicon. I'll send you this file. Do whatever you have to do. Give me an update by today night. Okay.
Yes, sir. Yes, sir.
Update means you have to run a system with the file that I'm going to send you right away. I'm sharing this file in Microsoft Teams. You must have your Surface file. That's necessary. Okay. Have you built it?
Uh, yes, sir. I extend that coordinate file. Yes, sir.
Can you show me that? What you got?
Yes.
Present it to me.